Okay, we're going to derive some formulas for regular polygons. Hey, let's see. Our first one, we're gonna what happens if we know the apothem? So little a. So we're gonna start with our basic formula. The area of any regular polygon is 1/2 of the apothem times the number of sides times the side length. Okay, this is your standard regular polygon area formula. So we want to have A, right? We're not going to worry about N so much right now. N is just the number of sides, and you can clearly count that. Okay, so we're going to leave N in our equation also, but we're going to try and eliminate our S. Okay, so we need to replace our S with something that has an A in it. So we got to find a relationship between your apothem and your side length. Okay, and if you've done any of these problems, we know that the tangent is what relates these two side lengths, because the apothem is the adjacent side and half of your side is your opposite. So it's the tangent of an angle of a right triangle that relates your side length and your apothem. So notice we have, well, of course, our theta is here. That's a variable. That changes depending on how many sides your polygon has. All right, so you can calculate theta pretty easily depending on how many sides. The side length and the apothem are your two letters that we have in your formula. So we're going to try and solve this equation for S so we can replace that S over here. Okay, and it turns out when we do that, when we multiply by A, we find that the side length is 2 times the length of the apothem times the tangent of our angle. Okay, and that's done with some algebraic manipulation. We multiply both sides by A, and then you multiply by 2 to get rid of the 1/2 to get S by itself. Okay, so what we're going to do is we're going to take that equation that we just made, that we know now that S is actually 2 times the apothem times the tangent of your angle. Okay, so that is what we put instead of S. Notice we only have your apothem as your variable now. We have A, and of course N, but N changes depending on how many sides you have. That's not really I guess it does change. It's variable, but it's a simple variable. So now we're going to spend some time simplifying our equation here. Okay, so that we can have one nice, neat equation that we can use at any time. So let's see what happens. We have some like terms, I'm sure. There's 1/2 and 2. Half of 2 is just 1, so we don't have any numbers in there. I have A times A, which is A squared. That's good, A squared. I have the variable N, which is the number of sides, and then I have the tangent of my angle. So this is a very simple formula if you know the apothem. Okay, and of course your angle is found by doing 180 divided by N, so there we have our N show up again. Right, that's your angle for your given polygon, and N is just the number of sides. So this is our formula that we're going to use anytime we want to figure out the area of a polygon if we know the length of the apothem. So what if we know our side length? Let's do the same type of thing. Now we're going to know what our side length is, and we're going to derive a formula based upon just the letter S. So once again, we start with area is 1/2 of A times N times S. The apothem times the number of sides times the side length. Okay, and if this isn't familiar to you, number of sides times side length, that's the perimeter. So maybe you've seen 1/2 of AP. Perimeter is the number of sides times the side length. So we would make a similar right triangle using our apothem and half the side length, where we still have our angle. And there's still that tangent relationship. The tangent of your angle is always half of S divided by your apothem. And in this case, we want to get rid of your apothem so that we only have S in your equation. which means I need to manipulate this equation and solve it for a. So we multiply both sides by a to get it out of the denominator, and then I'm going to divide by tan. So it turns out that the apothem is half the side length divided by 2 times the tangent of your angle. Okay, so the 1/2, right, the half stay on the denominator, and we're dividing by tan, which is why the 2 and the tan get together in your denominator. So the side length divided by 2 times the tangent of your angle. So that's going to come over here into our formula now. S over 2 tans of the angle. So everything else stays the same. We still have your 1/2, we still have n, and we still have s. So I have just replaced the apothem with its equal down here. So I'm using substitution, the algebraic concept of substitution. And now I have a formula that has s as my variable. So let's do some simplifying here. So let's look at all of our numerators. The numerators are all the stuff on top, right? AKA not a denominator. So when I multiply all those things together, I get n times s squared. S times s is s squared, and I'm multiplying it by n. And in my denominator, I look at all the things on the bottom. 2 times 2 times the tangent. Well, 2 times 2 is 4. And of course, the tangent is just the tangent. So this is my equation to find the area of a regular polygon. It's more than just a pentagon, even though that's what I drew, if you know the side length. So once again, the angle is just like before, 180 divided by n. N is the number of sides, and this is your formula if you know the side length to calculate the area of your regular polygon. So our last bit of information is, what if we know our radius? So the radius is the line that goes from the center to your corner. Okay, that is your radius. And we have 5 corners, or 5 vertices, so I can draw in 5 radiuses. 5 radii, technically, radii. And what we make are 5 triangles that are the exact same, right? This is an regular polygon, so all of the sides are the same length, right? These are all the same. And of course, every radius is the same. So these are a bunch of congruent, not equal that, but isosceles triangles. These are a bunch of congruent isosceles triangles, right? And there are 5 of them because this is a pentagon. Okay, so maybe you remember the formula to find the area of a triangle if you know 2 sides and an angle. Maybe you don't remember, but in case you do not, the area formula is 1/2 of the product of your 2 sides times the sine of the angle between them. So we can find the area of any one of these triangles by doing that formula. 1/2 of radius times the sine of your central angle. Okay, so in this case, we're going to replace your A and your B with R and R, right? Because they're the same. The 2 sides of your triangle, the radiuses, are both R. So our formula changes into 1/2 of radius squared times the sine of the angle. Okay, now because this is a central angle, the central angle is 360 over the number of sides. That's how we calculate it here, right? Different than when we had the tangent before. Now if we count, how many triangles do we have? Well, in a pentagon we have 1, 2, 3, 4, 5. But how many triangles would we have in a hexagon? 6, because there's 6 sides. And what about an octagon?
8.
We would have 8 sides. So because we're trying to derive a formula for all of them, right, if it's the number of sides that is determining, that variable is n. N is what determines the number of sides. N times our triangles, 1/2 of r squared times the sine of theta. So if we know the radius, we want to use this formula in order to calculate the area. The number of sides times this many triangles formed with the central angle and the radius. N times 1/2 of r squared sine of theta, where theta is now 360 over n, not 180 over n like it was before. Okay, so hopefully this is helpful and can save you some time in calculating areas of regular polygons depending on what side you know.